Hello and welcome to today's class. Look at this. How do we integrate or evaluate the integral of e to the power of tan x dx? So this is a simple one. Let's take our solution and see how we evaluate this. I'm going to touch all details in these questions, okay? How to arrive at the answer, I'm going to touch all the details. So here we have our question here, right? So the first thing we're going to do here is to do a simple substitution. So we're going to take our tan x to be something else. So we're going to say let's put u to be equal to our tan x. So if we have u to be tan x, then we're going to have our function here, y, going to give us here our e to the power of u, right? Good. So we want to differentiate this function here with respect to u here. So let's find our dy du. So we now have here dy du is going to give us what? This is e. We know that if you differentiate your e to the power of x, that will give us our e to the power of x, right? So this is still going to give us e to the power of u. So the next thing now is this function. Now I want to differentiate this function. So we're going to have our du all over dx will now be equal to what? Now look at this. We know from our trig identity that our tan x is equals to sine x all over cos x, right? So this expression could be written as our sine x all over cos x in this format, right? And in differentiating this, we have to bring in what we call the Pouchet rule. Okay, we remember the Pouchet rule, right? Pouchet rule says that the y all over the x, when you have your function, let's say you have your function y is equals to u all over v, right? So this will give us here our v du all over the x minus our u dv all over the x, right? Everything all over v square. We remember this, right? Good. So if we remember this, all we just have to do, look at our x here. So we're going to take our sine x to be our u, then our cos x to be our v. So if we come to this side now, applying this rule here, so let's put in here our v du all over our dx minus our u dv all over dx, everything all over our v square. So if we substitute, what is our v? We said our v is equals to this. So we're going to have here cos x times, what is our du? Now, look at our u here. Our u is sine x. If we differentiate sine x, that will give us cos x. So this is going to give us cos x minus, what is our u? Our u is sine x here. So we have here sine x, then times our dv. If this is our v, if we differentiate cos x, that will give us minus sine x. So this is going to give us bracket minus sine x close bracket all over our v square is cos square x, right? So let's continue on this side. Now we are having cos x times cos x, and here this minus, we times this minus to give us plus. So here we're going to have sine x times sine x. So automatically this our u dx is equal to, you're going to have cos square x all over, okay, plus here plus our sine square x, everything all over our cos square x. Oh, now from our trig identity again, we know that our cos square x, or let's say theta, then plus sine square theta is equal to 1. So if we have this, so automatically here is going to give us 1 all over our cos square x. And what is 1 all over cos x? 1 all over cos x, 1 all over cos x is equal to, or cos theta is equal to our sec theta, is our sec x here. And so this automatically is going to give us our sec, is going to give us our sec square x. So if we have this to be this, so we are having our du all over dx is equals to sec square x. So, all right, so from here, we can now evaluate our dy du and our du dx. So this now implies that our dy du the times our du dx will now be equal to, here, where's our dy du? Look at our dy du. So we have here e to the power of u times our du dx, which is this. We have here sec square x. But what is our u? We said our u is equal to tan x. So therefore, we cannot substitute to give us our e to the power of tan x times sec square x. In all, we cannot say, therefore, the integral of our e to the power of tan x dx is equal to our e to the power of tan x the times our sec square x. So this is the answer. Okay, plus c, please. Plus c. I almost missed that, man. So plus our c, where c is the constant of integration. All right. So thank you. This brings us to the end of today's class. See you in our next class. Bye for now.